those 2 trips. Be pretty summer.
You guys going to Hawaii?
July.
Okay.
Be there for a week.
Nice, man. What island?
Big Island.
Cool.
Yeah, and it's something that we've tried to do, of course, for the past 2 years, but just reschedule. Hopefully, we don't have to reschedule this year.
I think Hawaii for me was the first time my wife was telling me about it. I'd never been until we went back. It was about 4 years ago, right around there. And she's like, "Oh, you'll love it. And I've been all around the country. Haven't done much international travel, a lot around the U.S. And Hawaii is the first place I got to where I was like, I could legitimately just call my brother, have him sell everything at my house, and just stay here, like just never leave Hawaii. It just makes it a little bit tougher to work from that remote.
Right. I've been thinking of that too. It's like, okay, if we're doing a lot more remote stuff, it's like, yeah, team meetings, whatever it may be, let's just all meet up in Hawaii. It sounds great.
I've been pitching it to do that for a while. It quickly gets denied every time, but I'll keep on keeping on.
Oh, the next experience world. Let's do it. Let's do Hawaii.
In Hawaii? Oh man,
Could you imagine?
Be amazing. What about Arizona? Where are you guys going there?
In Phoenix, Scottsdale.
Okay.
Yeah, I think but it's going to be during the summer, and it's going to be blazing hot. The place where we're staying at has a pool, so I think we'll be able to stay cool.
Just jump in there. I thought that was a fun 3D experience world. I would definitely go back, do that one.
Yeah, I think Orlando or Anaheim, whenever you have a chance to have a special event at the theme parks.
Yeah, well, Florida, yeah, Orlando, that was really fun. And I was laughing at that one because at one point there was like, we did a roller coaster. At one point, it was at Universal Studios.
Yeah.
There was like 5 engineer guys. We were all standing around watching the roller coaster, not riding the roller coaster. We were having way more fun watching and talking about the stresses and the frequency of the roller coaster and wondering, like what the analysis that went into it. To like do a theme park with a bunch of engineers and designers that was super geeky. That was fun.
That was, we've been talking about like, when's the next time we're going to go to like Disney World or Disneyland? It's like, nothing's going to compare when you have like the whole park to just a group of people.
Yep. Yeah, that was when Bertrand was CEO, and I rode on the bus right next to him, and somebody got sick real close to him. It was a touchy time.
Yeah, no lines.
Yeah, that was
roam in the park. Almost.
That was my first world, actually, because like I was so blown away and just walk around the corner, and yeah, I was like, holy cow, they got just food vendors and there's free beverages right here, and I was like, I don't have any cash. I'm like, oh,
you don't need
walk
it.
up and take it. Like that was mind blowing.
That was kind of like right, but this is awesome. Yeah,
it was pivotal for my career. I was like, I'm sticking around these guys. These guys know how to do it.
They do know how to do it. I would love to do that again. I will say, I love roller coasters, love riding them. I mean, obviously, I haven't been on them in a few years, but no, I think it takes a lot to get like woozy or seasick. And I think the last time was actually when I went out deep sea fishing, and the heavy waves. I did not have my sea legs that day. But roller coasters, I'm pretty good. But there was it was the Harry Potter ride. Like I walked out of that one, I was like, oh, that one was rough.
Yeah, I skipped that one. As I've gotten older, I've gotten a lot more not as tolerant to motion. I've noticed even like swinging. I'm like, okay, after about a couple of minutes of it,
yes,
I need to step back. So it's something swing that sets. I'm not used to. But
I know, right? It's like the kids love the swing sets, but I have found that I can only do so many swings before like, oh, I gotta take a break.
Hey, you know what? Looks like we are live, and I want to thank everyone for tuning in. Solidworks Live Design coming at you. I don't even know how many episodes we are in on this one, but this has been such a fun of us to take part of, and we couldn't make it possible without all of you tuning in. So make sure if you're enjoying these, you want to see more, like, subscribe, and also, throughout the live design episode, I've got the chat right here. You got questions, you got comments. More importantly, if you have feedback or you want to share some insight into what you do and maybe other users could take advantage of, do it. Let's keep that chat super active. I'll be watching, I'll be monitoring. I can throw the questions right back to Michael Steeves, our special guest for today. So Michael, thanks for coming on, man.
Thanks for having me. Glad to be back.
Excited. I've got a little background on this one, but what are we looking at here? This looks like
you do have some background, and I wanted to show this. This was just gonna play this. This is one of those things where it's like you set up something in simulation, you run it, and you're like, I didn't even know we could do that.
I don't even know what's going on here. This is like,
what is this?
Man.
Maybe we should rewind a little bit and unbox kind of what's going on here. Because it is. It kind of looks like a box. It is a box. Maybe you saw in the thumbnail for this session. We've been working on this project, Lid Boss. I know, Mike, you and I have been working a lot on it. And as we start to get ready to tell that story, I thought, what a better opportunity than to come on to live design and do that technical deep dive and get into kind of some of the underlying features, how we did what we did, what's displayed in like a 9-minute video for this advanced simulation. So that's kind of what I wanted to do with you today is take a look at having a SolidWorks model and getting it to the 3D Experience platform, do some real world simulation. What does that set up? What do those materials look like? Because it's a cardboard box. Ooh, cardboard material properties. That's going to be interesting. I've had a lot of people ask about that over the years. And change happens. So design change. How do we have to recreate the simulation from scratch? Those are the kind of things that I'm hoping to talk about today.
Cool. I think let's go back real quick and just let's touch a little bit about the background on the product, because we might as well get the audience up to speed. So as Michael mentioned, over the last few months, us two and a few others here at Dassault at SolidWorks have been working with a customer. Actually, it's Center for Advanced Design. You've probably seen there on the splash screen, like the snowmobile was a big one. That one's been on a splash screen for like the last 5-6 releases. That's one of the designs that they did. They're out of my area. I live in Minnesota, so just outside the west side of the Twin Cities, about a 45 minutes drive. And we engaged with these guys because they actually spun off and created a new company called Lid Boss. This was before COVID. And basically the solution was a touchless lid dispenser, right? So looks like I'm getting just a heads up, guys. I got a little off sync on my audio video, so our producers are working on that. So we apologize about that, but we'll continue to work on getting that fixed. So yeah, their solution was a touchless lid dispenser, right? Think about going to McDonald's where you're trying to grab a cup of coffee, or you're at the gas station and you got to get that lid, and you're touching all the other lids, and all that germs that just constantly are getting passed on by the next person and the next person. Their solution was simple, just a way to take from the time those lids are sanitized out of manufacturing, put them in a sleeve, and then they're never touched until the actual end person can take the lid. So they can wave, touchless device, think of a sink, wash your hands, wave out, and a lid is dispensed, put it on your coffee cup and go. So we engaged with them. We thought, hey, it'd be really cool to learn about your challenges of the design process. So things like, what were some of the critical design parts? What did you guys do for simulation and validation? What about working with all your vendors? What we learned is that they actually released their product right before COVID hit. So they had a really viable design, they're ready to go, and all of a sudden they had this global demand to ramp up their production. So it's a really cool story. Keep an eye out for more of that to come. And next week you'll see we're doing a SolidWorks Live, more specific. We'll have those guys on, Mark and Jesse from CAD, to talk about LidBoss. And we'll also have a full microsite available coming out next Monday. So today, one of the most interesting parts of the story was learning about, hey, you got a product that's in global demand, you got to ship it. And these things aren't necessarily the cheapest things, so you got to get it to China or wherever it might be in good packaging. And so that one little backstory there. And Michael, if you have anything else to add, but I'll let you kind of get into, that was the task I sent to you. I was like, we need to virtualize the drop test. Can you do it? And you said, oh yeah, I can do it. It's going to be awesome.
Yeah, there's so much to that story. And yeah, next week we're going to kind of tell from prototype to production story next week. And there's going to be website and more videos to come out and share. So yeah, we could spend all day talking about the whole LidBoss story. Yeah, but this is our opportunity to kind of get in behind the scenes a little bit, if you will, of that story of what went into, okay, all right, Michael, let's do a drop test, a virtual package drop test, and see what we can do. So that's where to start? Well, we started in SolidWorks. The LidBoss uses SolidWorks to design their product. They did the initial packaging layout, and I took that inspiration, actually took the inspiration from their story, and we'll probably reiterate this, in the content to come. But the design change that we echoed was a first package prototype, and actually let me show you this first packaging iteration here in SolidWorks. It's foam and cardboard. And we do have some simplified representations there of the LidBoss. So just kind of that a surface representing that outer shell of the LidBoss model, and the what do we call it? The gravity tube.
Gravity tube. Yep. So that's
the gravity tube.
The lids go into that thing.
Lids go into this. It rotates 90 degrees, goes into the top, dispenses those lids. But yeah, this was the kind of initial packaging layout, if you will. And so right now, I guess all these, to get this to a point where we're ready to run an advanced simulation, and one of the things when we talk about advanced, it's like, well, okay, in this case, drop test. A lot of contact, a lot of nonlinearities happening in a very short amount of time. So that's where, okay, Abaqus comes to mind. And Abaqus is actually the technology that we're using on the 3D Experience platform to do these advanced types of analyses. So kind of one of the first steps that we can do is connect SolidWorks to the platform, and I'm sure a lot of you out there are probably using SolidWorks desktop, and you can easily connect it to the platform and leverage the wide range of roles and applications. So right now these files are local, but integrated into SolidWorks. We have the platform, and we can do that. We can do that save. So
Michael, real quick, I want to point out, because I always thought this was cool, and it was something, as I saw it progress and working with other customers, is doing packaging design in SolidWorks. And I don't know if there's anyone in the chat that's done this, but you can actually use the sheet metal functionality to create your flat pattern, right? So like that's what they did here, is go through, create the structure around the LidBoss. You have that overall box structure, and I've seen really cool examples where you have let's see, there's an AE that did like a full mask, an Iron Man mask. He designed it up in sheet metal, used some bend parameters that you would get out of cardboard, right? Because you have there's really no, just that perfect 90-degree edge internally, but then you get that flat pattern out of it. So you can actually use SolidWorks, which for sheet metal design to do packaging like this. And so anyway, I wanted to share that and see if anyone's doing that in the audience. Let us know. Packaging design is such a cool thing to do inside of CAD.
Yeah, definitely. I mean, take a look here, because with using sheet metal inside SolidWorks, it's in every version. We can generate that flat pattern, and there it is, right there for our box. Because yeah, that's definitely an interesting concept. And now I'm inspired by what Jeremy did a presentation on live design.
Oh, that's right. Yeah.
Was it last year or 2 years ago? Man, these live designs are going by
2 years
fast.
ago
We have
now,
built
yeah.
up quite a big library. But Jeremy did a packaging presentation, showcasing how you can use the SolidWorks sheet metal features to, do packaging design.
Yeah, super cool.
So there it is. And yeah, with a couple clicks, it's right there. It's saved right to the platform. So what does really that mean? Well, instead of stored locally on my machine, it's now on the cloud. So I could go to another machine, open it from there. In addition to that, I can I can open it in a variety of other applications. So like the simulation guy that you and I are, Mike, we have access to a variety of simulation tools. If it's structural analysis, fluids, plastic injection molding, and more. Electromagnetics is one. I think there's this story of the e-bike that has recently come out too that showcases.
Yeah, there's a lot here, and Michael, my background, I used to teach the simulation class for SolidWorks, so I guess for the viewers out there might be interested, we know we have SolidWorks simulation available today in desktop. Where or why would be, why would I go up to use these Abaqus solvers? What's the big reason to kind of jump to the next level, I guess?
Yeah, so there's many reasons. Just talking about the power of the cloud for the moment, because we do, with this, the level of collaboration we have is improved. I remember one of my first, before I got into my first job in industry, I was shadowing one of the design engineers at one of the local aerospace companies here, and I'm in Bellevue, Washington, at the moment, just outside Seattle. A lot of aerospace support, as you might imagine. But I was, shadowing one of the engineers there, doing a design change based off of some simulation results. And the reference he was using was, just a printed out, a couple pieces of printed out paper, kind of a simulation report. It's like, I couldn't interpret it. It was my first glance at, FEA results. I'm like, how do you know what to do and where and why? And so he had to go, do a lot of interpretation from these static images. So that's where this level of collaboration, leveraging the cloud, is definitely improved. So as if you yourself aren't doing the simulation, someone else is, how do you share those results? Now 3D,
Sure.
common platform, easier to find, easier to share, all that information. So that's one aspect of the power of the cloud there. The other is the speed of the results, and we'll get into this a little bit later, I imagine. But being able to solve faster, leveraging high performance computing power on the cloud, right? You can set up the analysis just as you want locally on your machine, and then submit it to execute and solve on the cloud, on a server somewhere separate from you.
That one's huge because, I think I've heated my house through a
Yes.
lot of our Minnesota cold winters by running studies, especially nonlinear studies, 8, 10, 12, 14 hours on my laptop, just cranking away, oftentimes with having to restart it. So yeah, having to send it out on the cloud compute that's a big benefit for sure. All right, cool, man. Well, I'm excited to see the process here. You got in SolidWorks CAD, right? We've got the design. The design's done here. We talked about that. We got the cardboard. We're leveraging that simplified assembly for those that aren't, aware of some of the process and simulation. But you try to find areas that you can simplify it. For the lid boss, we didn't need all the gritty, nitty detail. We just needed that mass, basically, and some of the geometry to reference. And now you're sending up to the cloud, or sending up. How's the
That's right. So now it's a part of the platform. So now I can easily access that data for the plethora of applications that are on there. So actually, one thing that we just did here now, let me just update this, because I did. When I saved it up, I actually saved a couple extra components there. So I need to make a little design change and update it here. But one of the important thing, especially from like SolidWorks users, if you are taking your CAD model and going to any other analysis package, So, I mean, if it's SolidWorks simulation, of course, it's integrated right into SolidWorks. But if you're going to Abaqus or maybe something else, sometimes you have to do like an import process. Not here. We're going to a separate application. However, since it's all on a unified platform, we just open it up and there it is. So it's super easy to open up in these other applications. I guess that's one of the other benefits of the platform here is, there's no conversion that you're having to do as a user. Yeah. So
me in Minnesota, you in Bellevue, Washington, I could be working in the design real time, and you could just start cranking on a simulation on your end. No email, no nothing, huh?
That's right.
That's awesome.
You think of other, social media or other collaboration tools where you can like @mention people, call them out on that platform. It does the same thing here. So, yeah, and it's integrated with SolidWorks. So yeah, launching it right from there gets you going. As you can see here, I've got a couple revisions that we'll be taking a look at in this. And I should clarify, the simulation tools that we're running with here are locally installed, just like SolidWorks. So it does. I mentioned being able to solve on the cloud. Of course, you can solve locally. But again, yeah, if we take a look here, there's the same SolidWorks geometry right in there. So one of the first questions is, okay, I mean, how can I, create like we're doing a drop test here. I think we're talking to Mark and Jesse at CAD. It's like you can, if you're going to ship your product around the world, how are you going to validate that packaging? Well, you could send it out to some of these independent packaging validation places that perform these battery of tests to do it. But yeah, like the question is, how can I make the initial design better, before we get to production? Same question applies to packaging.
Yeah, so little backstory on that is they actually, once they had their packaging pretty well set, they paid a good chunk of money to get this thing shipped all over the place. I mean, to and from East and West Coast, up and around and down. So you've got not a day, not days, but we have weeks and weeks and weeks of physical data of this thing being shipped around via different, shipping methods to get that data back to then analyze it. So a lot of money and especially a lot of time. And remember, this is COVID just happened. They released their product. They didn't really have that. So being able to validate it virtually, there's a big benefit there.
Absolutely. So, taking a look, one thing that we can do here is start setting up the scenario. So let me actually take a pause moment here, because part of what goes into this is, if anyone's familiar, I don't know what the chat's looking like of what they may think the next step would be of setting up a drop test. But we mentioned earlier we got interested in materials.
Mm-hmm.
So let me actually just take a quick moment here to take a look at some of this, because with that cardboard material, there's cardboard, there's foam, there's some plastic that we're representing with those components. So we can, and this is some of the benefits of using Abaqus here, is the ability to accomplish some of these highly nonlinear applications.
Yeah, so in the chat, maybe what would make cardboard, or maybe I'll give a little hint, corrugated board, more difficult to analyze in a simulation model versus like a standard 661 or even just like a basic 1020. See if anyone out there might think about that. Why is this so cool to see that we can actually analyze corrugated board versus our standard metals?
And I was, get shipped packages. I look at the cardboard almost every time, and you take a look at, oh my gosh, how many, layers of cardboard are in there, the different thicknesses, if they're, multiple layers glued onto each other and then used. So a lot goes into that cardboard design itself. It's a science of its own. So what I've done here is I do have a kind of simplified material model to represent that cardboard in the two directions. And as you can see here, we're representing that nonlinearity of the plasticity of the cardboard.
There's a ton of different material models in here. This is, I know some of the capabilities in the desktop stuff, but
yes,
like hyper foam, wow.
Yeah, so you can see, of creating a material definition here, on the left-hand side there's a lot of different things that we can do inside structures and the multiphysics of Abaqus. And the ones that have that little orange dot, those are the ones that we're using. So of course we need properties like density. Here's our elastic property here for our different directions of the material. There's that plasticity, and here's our culprit here of, how were we able to have that first simulation we look at, to have it blow apart, disconnect, elements are dying, it's damage.
Wow.
So we have some damage enabled here to account for that element death.
So in Abaqus, you can actually figure out when stuff completely fails. Is that accurate to say?
Right. So we have a fracture strain that's defined here to account for that. Yeah. And there's, this is something where you do, physical testing, you do some correlation with the data to account for that and bring in these different material models. Again, like what I mentioned here, this one's a simplified model, but, it doesn't have, one cardboard material doesn't apply to the various types of cardboard, corrugated cardboard board that we were talking about a minute ago. So yeah, that's where you could have multiple materials, and you could toggle between. That's part of the design process. Is, well, you could change the geometry, but what about the material? So you could switch between different cardboards to see which one is going to work best, in your case.
Really cool. Really cool. Yeah, so those in the audience that are familiar with the desktop simulation, so in just static analysis where your stress strain is linear, so you hear about linear statics, we're really analyzing the deformation that happens in that line. Outside of that line becomes a nonlinear type of deformation. There's there's your stress field, your curve right there. And SolidWorks can do that. There's a nonlinear solver there, but it's a little bit more limited. Once you get into these, you can see what Michael's got up here, all these different ways we can validate different materials. And we all know, in today's technology, we're constantly creating new materials and finding new materials or new ways to manufacture materials. That adds a lot of complexity. This is where having the power of the Abaqus solver, you can actually go through and really, really fine tune and create those different materials and solve all the way through into failure. So that's like huge to a sim geek, is that material model is that's really powerful.
So maybe I'm going to fast forward here a little bit and take a look at one that was that I have set up here for this first iteration. So one question that does come up is, okay, the different types of scenarios or procedures that you can create, and this capability keeps expanding every release. So actually down here, if we look at the bottom, when we set up an analysis case, we have our procedures, and we can do things like, you mentioned what we can do in SolidWorks simulation and desktop. We can do things for linear statics. We can do buckling. One thing that's unique about here is we can do the RICS buckling analysis step. We can do different static perturbations. Then we get into our dynamics, so implicit dynamics, which is what we use, that type of approach for our nonlinear capabilities in SolidWorks simulation. But then we get into the explicit dynamics, so the explicit, and then we get a little bit in the explicit in SolidWorks simulation with the drop test study. You think, oh, maybe that's where we can accomplish a situation like this. But again, once we get into kind of the more advanced materials, that's where we would really differentiate here using these roles here on the platform.
Hey, Michael, we got a question. I don't know if you can answer this one. I know you worked with the Simulia team on the material model, but Ken's got a question. Are you using ECT or Mullen on your test for the corrugated?
Ooh, I don't know that off the top of my head. We'd have to get
All
back
right,
to that one.
we'll come back to that one. Great question, Ken. Keep them coming, guys. If you have questions as we're going through, whether they're simple, basic questions on just simulation, all the way into material theory, throw them in the chat. We're happy to engage and see if Michael can hit on those. So keep them coming in, guys.
All right, so then we get into, I mean, for those of you familiar with SolidWorks simulation, like I know you are, Mike, we get into linear dynamics, frequency, those sorts of things. But a couple big differentiators here in this realm is we can do complex frequency. So actually we did worked on a project like this a couple years ago and there's many papers out there for brake squeal. Right, so we're if you're braking on your car and you've got that brake squeal, there's harmonics that are going on there, but there's also contact that's happening. So being able to quickly analyze, that type of phenomena is capable with the complex frequency. And most recently added here is our response spectrum analysis. Cool. So the types of studies that we're doing here keep on expanding with what we can do. And of course, if there isn't something there now, let us know. We'd be happy to work on getting it in there.
So it all goes back to, we all know failure happens in engineering, and I love the saying, fail early, fail often, right? We want to try to virtualize those failures before it goes into production, before it goes to market, before you're shipping 100,000 units all over the world, right? In this case, and failure is not always just that linear statics failure. It's not always just the metal has yield. You've got almost a half or a dozen different ways to look at. So keep that in mind as you're designing, what type of physical outside real world conditions are happening to your product when they're in use, and can you virtually validate all the way through beyond just that static failure that we're all pretty well familiarized with. That's really cool. That's a lot of different ways we can analyze.
So so let's talk about the setup a little bit. The setup here wasn't too complex, and actually to help walk along here, we do have an assistant that's built in to walk us through kind of setup, defining the parts, connections, and mesh. I know one thing last year when we did our other project, Mike, with the shredder, in that episode of Live Design, we did get into some of the meshing techniques, so I'd invite people to go back and watch that one. I want to talk about a little bit more about this explicit study and the setup here. So this is something when we define that procedure there that we had at the bottom, can we specify, well, how long do we want to solve? And as you can see, it's a small fraction of a second that we're accounting for. So you may think, oh, how do I set this up? Do I have to move the model up above, account for the amount of time it takes to drop down? And the answer is no. So as you can see here, the initial condition or the model placement is where that box is about to hit the floor. So and that's actually something where we have access to additional applications. I mean, I could set up that geometry setup right inside SolidWorks, but we didn't. We actually pulled that final package into the model, and we actually inserted it into a new, what we call a new physical product, which is right there. We modeled in a floor. There's our mesh represented there. We'll leave that aside for now. And there's that SolidWorks model. So we're able to kind of actually combine both SolidWorks and CATIA to generate the geometry and perform the setup. So that's
a question came in here too on, can we also view, and I know we'll get to results, but view the accurate deformations?
Yes. Yeah, let's take a look. We'll come back to that in a little bit, I think.
Awesome.
Okay. So just to step through here, we have an initial velocity, 6 meters per second, headed down. We have it applied to all those bodies. For interactions, I've talked about this many times, but when it comes to interactions, we just specify a contact property, like what's the friction that's here. So we have always think of, and there's plenty of internet memes on there of especially engineering memes, like when the physics professor tells you to ignore friction. like, oh, the problem's super easy, but it's not realistic. This is where, friction is definitely in the real world, but we apply that with just a property here. You can individually assign it to different regions if necessary, but I have it globally defined here. It's part of a general contact overall. It's applied to all surfaces, so everything that comes in contact, automatically recognized. This is one of the other big benefits of using this, these roles on the platform, compared to other tools. It's that contact detection is amazing and automatic. From here, we have a clamp that's applied to the floor.
Questions coming in. We've got Martin is asking on, is this SolidWorks Premium? And the follow-up question is, where are you performing these analysis? I think you may have missed the kind of that intro part. So just to refresh on the data workflow here, the process.
Yep. So the CAD model is coming from SolidWorks. There's our initial cardboard, packaging design. That is being saved onto 3D Experience and then opened in one of our roles, or one of our apps. So this is the mechanical scenario app that we're looking at right now, part of the structural mechanics engineer role, which is a collection of these apps. So this is where, with that, when I mentioned earlier, if we just take a look at, some of the other tools that are in here to create that assembly, was using Assembly Designer to do that material definition that we talked about earlier. There's that app. Here's our scenario creation. And you can see there's a variety of other tools here to help, perform those different tasks to perform the simulation.
And now these apps here, we do have on the platform, we offer like full cloud-based enriched apps, like you've heard of XDesign or XShape, which are browser-based modeling applications. This one you're working with, though, still has an installation. Is that correct?
That's right. Yep. So okay. These are what we call like native apps. They're installed on your Windows machine. Yep. But one thing with the results, when we do that post-processing, and we can get there in a little bit, is those can be shared and viewed right from your web browser.
Cool. Yeah,
from
that's
your
huge.
phone, or even integrated right into SolidWorks. So if you share those results back to the designer, you can have those results right in that right-hand pane to help drive those changes that you're going to make in SolidWorks.
All right, so we've gone through, talked a little bit about, we've got the data, looks on top there in the model side. Now into the scenario, we added some friction, right?
We added friction. Yep. We added a clamp to hold the floor. We added gravity to everything. And then I think, maybe let's talk about solving a little bit here. So when I submit these jobs to solve, you can choose. You can solve it locally on your machine because it is a locally installed client, like we've talked about, or you can send it up to the cloud. Now, what's really powerful about these roles is the capability to solve on the cloud is available to you, kind of at no additional cost. So, if I'm submitting this job, I can choose however many cores I want on this, and I've solved this on this laptop here. It's 6 cores. Of course, it's hyper-threaded. But we're solving this on the discrete cores, so I can choose up to 6 on this machine. No additional tokens or credits are consumed here, so I can do that locally. Or, as the other option here, I can choose to solve it on the cloud. And like I mentioned, with the structural mechanics engineer role here, 8 cores is included, so it's not consuming any additional tokens or credits. However, you can purchase additional tokens and credits so that when we're solving on the cloud, we can go up to 18, 36, or even 144 cores.
Whoa, that's a big machine.
So that's part of the power of the cloud, that high performance computation. So actually, I had this question come up of, okay, why 4, why 8, why 18,
yeah,
why 36,
kind of a big,
right? It's like, well, what if I wanted 50? Did I do 50? So yeah, a couple things there. I mean, with 4 and 8, these are the levels that are included. So we have different roles available depending on the type of analysis work that you do. Depending on that role, the capability of 4 cores or 8 cores are included. So that's where kind of the 4 and 8 come from. But from there, the logic behind 18, 36, and 144, it's coming from what we're solving, what type of structural scenarios, what type of fluid scenarios, plastics, etc.
Sure.
And what we've done, what development did, is we found a balance to optimize what's the best core options, and also, like, when you run it on the cloud, what cloud resources are you using? Because as you imagine, right, the cloud isn't free, right? If you wanted to spin something up on like AWS or something, you can pay to use that piece. But when you go and consume that resource, you have to say how many processors do I want on that virtual machine, on that cloud machine?
Sure.
Right. So if you say, oh man, I want a cloud machine with 1,000 cores, but you submit a job of 18 cores on there, you've got a lot of room that you're not using, but you are paying for. So there's a balancing act here that's made to give us these options here for that 18, 36, 144, and it scales quite nicely. And when we submit these jobs, so actually solving this study on 144 cores took about 20 minutes.
Wow.
To solve this compared to locally.
More than that.
Compared to locally, when I ran it on 6 cores, it takes about 60 minutes.
Okay, which was still not bad at all. That's a lunch, right?
It's a lunch, yeah. And you can think, we did a lot of simplification in this model that we took a look at earlier. We're missing a lot of these smaller features here in the model. The entire gravity tube is just simplified with a surface extrusion. But you could throw more geometry, more complexity out there, and leverage the power of the cloud to do it.
So a couple questions in here for you. One is, and maybe I can help answer this, can we have these apps in already purchased subscriptions of 3D Experience? Michael, do you want to take that one?
Give that to me again.
Can we have these apps in already purchased subscriptions of 3D Experience? So I'm guessing they've got, probably that the if we and the business or industry collaborative innovator roles.
Yeah. So
is this included in there?
Maybe to help answer this. So
there we go.
What we've shown earlier is we've got 3D Experience SolidWorks. That's where we made the model. The other option there is have collaborative designer for SolidWorks that connects SolidWorks desktop to the platform.
Mm-hmm.
Here's our collaborative business innovator. So this is where we get our dashboards and more. Once we get into storing cloud data, the SolidWorks data on the cloud, this is where we use one of our prerequisites, collaborative industry innovator. So is it included? No, it's an additional role, what we're doing here to set up this simulation.
Yeah, so essentially if we were to include it on that basic one, that cost of entry would go up. We really want to make it so it's, if you're doing design work, you have a design role specific to what designers are needing. If you're doing more simulation stuff, you can add that role in as needed. It's going to come with all the apps that you need that Michael showed, like that material definition app becomes available to you that you don't necessarily need that if you're doing more of just design type work. So when you look at the 3D Experience platform and you look at what you do, whether it's, a workflow or an industry that you're working in, we have roles very specifically kind of curated for your work. So you're not getting more than you need, but you can add those on as needed, and they become available to you right away, right through the browser. You can start to launch or install to be able to tackle those challenges. Another question for you, and let us know if you have any more questions on that. Will these features be added to the offline SolidWorks program, or is this only accessible on the online service? And I think this gets into looking at what's available today with the desktop simulation tools, and as we kind of value up to the Abaqus type solvers. Do you think we'll ever see this?
Yeah, these roles that we're showing here and leveraging the power of the cloud here, submitting it to run online. This is all part of 3D Experience on cloud.
Yeah, I think one thing to keep in mind is the simulation rules available in the desktop apps are really focused and honed in on that early design process. You know how to make those decisions when you're kind of in that if then scenario. As you get further down the development cycle, as complexity gets more involved, your decisions come a little bit more costly to making a bad or a good one. This is where you're going to start to want to go into these very powerful solvers that not everyone needs. The desktop simulation tools, we see a need for any designer, any engineer to use those, in that early phase. But as we progress, so the answer to the question is, we probably won't ever see, and I can't say never on this stuff, but this type of level of solving in the desktop app, because we have great tools that are available today for that design aspect of it. Yeah, keep the questions coming, guys. These are great as we go through, and hey, we're seeing some results. Let's what are we looking at here, Michael?
Yeah, so this is our displacement plot. So we can see how those foam components, we've done a section view right inside here. So we can see kind of how these components are interacting, how they're colliding. And one thing I won't get into it today, but we actually attached virtual accelerometers on these to take a look at the accelerations about there. But I think for our time today, Mike, I think I'll have to have everyone go to the videos when they're available to go watch.
Right, pretty pictures, and we have I see there's a displacement graph there, but yeah, the accelerometers to me and you guys have to check out the videos again. That'll be available next Monday. The microsite and emails will be coming through. That's where like the good data, right? The fun stuff to really start to analyze comes in.
Right. So I think one thing that we see here, it's like, oh well, it could be performing okay. That gravity tube is unconstrained. It's able to move around there a lot. And we did only solve this kind of for the initial collision of what's going on here. But there's so much happening in such a short amount of time. So I think really going back to, okay, well, let's come up with the initial design. Let's do a virtual test and kind of set that up. And of course, change is bound to happen. And I think that the story with LidBoss and the change that they had to make was they shipped it out to a restaurant, their initial package, and they opened it up the restaurant, and what did they see? They saw the styrofoam foam. They saw the foam. They're like, no go. We can't have foam in the food industry.
Yeah, so, the NSF standards, is that the food and safety standards in packaging? And kind of a fun fact, if you're ever doing packaging design for food, you cannot have foam. It has to be cardboard only and plastic wrap, right? Plastic they can include in there as well, but no foam.
Right. So, quick change. It's like, well, I maybe you've used foam before.
What you think about, impact, right? Think of a car's bumper. You ever take a bumper off, rear bumper of a car? They have super high density foams in there because foams do an extremely good job at crunching during those impacts. So why wouldn't you want to use foam in a drop test in a box like this? But you can't. That's why.
So they had to resort to a all cardboard design. So maybe we'll use that one that we created earlier. And this wasn't, fully set up by any means, but this does show kind of the foundations. There's our physics simulation at the top. We've got our CAD model. This is where we create the scenario and results and do our post-processing. But I think just to keep this simple, let's just focus on this CAD structure here. And because we're saving onto the platform, revision control, revision management is built in. Everything's kind of saved at this A1. So let's just talk about what it looks like to do this revision change and go through that process. So I need your help, Mike. Help me remember the structure here. So we've got this 1988. That's the physics simulation of interest. We want to revise that and the component inside. But actually, I really only need to remember kind of one object here, that physics simulation. So that 1988. So when we come to, let's just do this. Let's just take a look at all of our simulation objects that contain that 1988. There it is. And right on the platform here, you can see like there's other filtering and on the left, there's other properties on the right to help me understand what I'm working on here. But the change I want to make here is we're going to revise it, right? So why would we revise? Well, obviously we'll want to keep maybe what was released or the previous iteration so that we can do that comparison between, to help validate the change that we made. We can also preserve all the work that went into that simulation setup. So you don't, have to, lose previous work that you've done.
Gotcha, yeah.
So in this case here, we want to do this revision of, we're taking a look at all the relations here so we can continue to branch this out
cool.
as we may see. So there's our physics simulation. It contains that CAD model, all the components inside.
So for the SolidWorks users that may have dabbled in Treehouse,
yes,
Treehouse was a really cool project, still around. Gives a nice visual layout of your top level assembly, sub-assemblies, any affected components in there or reference components. This is a really cool way to visualize that. And you're doing it from a simulation, is that top level.
Right.
And now we're seeing the CAD files and all of the subsequent parts in that. That's really cool.
That's right. Everything on the platform has these relations. We can visualize them. So it's definitely, it's more than just the design data.
Yeah. So this would be neat too. Like if I wanted to make a change to the foam model or maybe, one of the packaging structures, I'm guessing that would give me if it was anywhere else outside of this, if it's reused in another assembly, we can't obviously just dive into making changes if it's released in another.
And you would, right?
Object.
And I can validate that. Sure enough, this cardboard box, for instance, it's only used in one location.
Cool.
So here it is. But if it was used in like other assemblies, or maybe if that foam model was used elsewhere, that number would be higher, and we could see where else that is branched out and used. So I could say like, I'm going to make a change here. Yes, it's only limited to here. I don't have to worry about what other things this may impact. All right, so let's do a revision of that physics simulation and of that CAD model. So from that relations, I can select both objects, and we launch our collaborative lifecycle app is what we use here. So this does a couple things. This is where we can go to like delete data. We can go to release it. So we do have definitely some life cycles here. And also revise them. And I can revise them together. So that does a couple things for us. So we could put in a comment here. Our cardboard only version. So we're kind of creating this revision. This is also interesting because if you've used like SolidWorks PDM or some of these other data management tools, you can have some of that capability right inside SolidWorks. And sure enough, we do. With the platform in SolidWorks as well. But because we're, managing data from different applications, we have one app to bring it back together. So I can perform that revision process on multiple types of data that are connected.
Hey, we got Sean O'Neill had a question on here. You pulled up that sim result just by that prefix of sim. Is that really how easy it is to just to take a look? Yeah.
So there's tons of types of content that you can bring in here, and if you are a 3D Experience user now, take a look at this. Or if you're not, this is one of the pro tips is if you hit this little drop down here in the search, you can go to Help on Type Shortcuts. That gives you a list of all the different types of objects that we can have in here. So like the object that we were interested in, it's a physics simulation object, and you can see it there in that collaborative managements. So if I just type physics, there it is, physics simulation. So one other type is just do phys or physics simulation. Okay. So there's
it's a handy tip.
Type simulation. There's ergonomic simulation. There's my physics simulation. There's simulation jobs for submitting a simulation job to run on the cloud. There's our simulation sim. Looks like I could have just used S as well. So yeah, great type shortcuts to just easily filter your search right away. All right, so there's our new revision, our A2. And if I take a look at the relations of this one, We can see there, sure enough, there it is. And here's the big question. It's like, is it attached to the A.2 of the CAD model? And sure enough, it is. So that's cool. So let's
Michael, got one more question back on Ken, another good material definition question. But he's wondering about the corrugated direction. You know, I know we're using a simplified model. Are you able to do those iso or orthotropic type direction definitions?
Yes, of course. And that is, yeah, we didn't get into it today, but when you define the properties for those components and select the material associated there, you know, it does have orientation directions. Cool. And I think if you go rewind back to when we had the material model up there and had the plasticity or the elastic material property, it had the 3 different directions there.
Yeah, so it's very similar to a composite. I mean, essentially, cardboard is a composite. If you by definition, and you can define those different strengths X, Y, and Z. We have a lot of customers that work in composites that heavily use Abaqus solvers to figure out what is the optimal orientation, because sometimes you want a lot of flex in one direction and maybe not so much in the other. So yeah, you can definitely define all those. Ken, another awesome question. Thanks for chiming in.
Okay, so taking you back in here to wrap up this revision kind of sub story here, we can see that we have it opened up in our mechanical
A2
scenario app. There's our A2. There's our A2. We're able to keep going on some of the work here, but our geometry hasn't changed. And sure enough, because we haven't made that change inside SolidWorks. So let's jump back here to SolidWorks, and we can grab the latest version of this model. So there it is. I can get that latest revision right from the cloud, pull it down into SolidWorks. And we'll see that, sure enough, yeah, our tree is updated with that A.2. That's great. We can see that verification here on the left-hand side as well. This was one of the recent enhancements in our SolidWorks Connected, is having this built into the feature tree, having this feedback of what's happening on the platform.
So I'm seeing we've got A.2. It's the green check is, what does that mean?
Latest version.
Latest version. That's important. What about the little lock symbol? I'm guessing ownership.
So right now it is not locked to me. So we will make that change here, but let's go ahead and add the change here. We're going to add some of these cardboard components here. Let me hide this so you can see some of the changes here. So we just added. Actually, let's do this. We need to remove these. Let's just suppress them and add in the other cardboard components. There they are. So you can see a number of things that are added here. We've got some W's, a V, to build this thing up and add some rigidity. And we can see, sure enough, on the right-hand side, platform's aware. Okay, when we make our change here, we have additional components. We've removed some components. Let's go ahead and save our changes. And sure enough, it's actually prompting me. Hey, you're trying to make a change to this model. It's not locked, but in order to make that save, you need to lock it. Well, I forgot to. However, I can just easily lock it right from here, so that I'm telling everyone, on our design team, hey, I'm making the change. I'm submitting this change to the model. And sure enough, after I'm done, I can unlock it. So if anyone else wants to make changes to them, they can reserve it. They can lock it for their use. But that's a great way, to use something as reference and build up, your assemblies without accidentally changing what's stored and what everyone else is collaborating with. Now, okay, so let's switch back to that A2 simulation, because here we go, right? The model hasn't changed here, so we're out of sync. So to make sure we're in sync, I could close and reopen everything, and that'll pull it the updated model. Or we can do something what we call here as a global refresh. So it's taking a look at what's in session, what's open now, and what's out of, what's on the server, what's on the cloud. Sure enough, it recognizes that, nope, it's out of date. So let's perform that refresh. So it performs that update. And it looks like, we'll do that one more time, because it was performing that, when we add new components, we talked about how you don't have to do any conversions manually as a user, but it is doing those modifications up on the cloud. So there's those, and we can pull those changes down. Sure enough, yeah, we've got all those additional cardboard components in there.
So, Michael, we've got about 3 minutes left till the top of the hour here. But one thing, when you do this, we've seen the update in design, and we know revisions will happen. They're going to happen, especially as you're getting that feedback loop. You're doing your simulation, you're getting information, it goes back to the design. We can really start to, again, fail early, fail often to get that optimal design. What about all of the loading and the clamps and the accelerations and everything that you went through? Do we have to go through that process again on this new revision?
No, all that's maintained. So like as you can see here, we have the updated geometry from our A2 performing that update. So let me switch back over here to our A.2 results, because really the only thing that at a basic level, the only thing that needs to be updated is the mesh, right? The new components
right,
need
new
to be
geometry
meshed.
we need.
Geometry needs to be meshed, but the intelligence between face IDs and that association between the simulation and the CAD model is maintained. That's so we save a lot of time. You don't have to recreate the simulation. All those loads and boundary conditions are maintained, so that you're able to get to that solve button much faster than any other tool to do the post-processing of the results. So yeah, we can take a look at some of our results here. We'll generate a cross-section here in a moment. Yeah, so really leveraging revisions. Now we can even do a design comparison, side-by-side look at these two, see which one is better and see how they improved. So I think that's where I'll give people we do the comparison of the accelerometers in the video. So we'll drive people to take a look at that.
Really cool.
All right, so let's do a cross section here. Let's see how well these guys compare.
So again, the idea here, we're trying to take that impact load and channel that into the cardboard and around that primary, that base unit that has all of the mechanisms. There's 4 different servos inside of there, a PCB inside of there. So we won't show the sensors themselves, but those little accelerometers, virtual accelerometers, actually show the change of how you incorporate different materials, different structures in the packaging can reduce the amount of acceleration at certain locations, critical locations of your design. Man, I love this animation. I could watch this all day. Someone said earlier, like, "Oh, I love all the colors. Just love it." Yeah, Juan, you nailed it. That's so cool.
Yeah, so we can take a look at velocity, accelerations on these color plots. I mean, yeah, you could get lost in just watching these results for sure.
That's so cool.
I think no, unless there's any other questions or anything that maybe we want to plug for Lid Boss and that story that's coming out. But we were able to talk about what went into creating this real world simulation, the different nonlinear materials. Talked about leveraging the power of the cloud for solving. Oh, one other thing that people are going to be able to see in the videos is when you submit a job to run on the cloud, and this actually happened to me when I was setting up this demonstration was. Wait, did I forget to set up?
Oh, your opening video. We didn't go back to your whole explosion mess.
Yeah, did I forget to set up a boundary condition? Did I accidentally, moved a decimal point in the wrong place because this first
that's what
first
the
analysis
first one
that
we
we have
started
here,
with.
it's like I think I had a decimal wrong place.
Man, could you imagine doing a physical test and that actually happening? Be like, whoa, I definitely think we're living on a different planet right now. This doesn't look right. So you see the validation as it's going through the study. You can start to see like, oh man, I got to stop, not waste the time, come back and reinvestigate. Oh, I'm happy that's not what the lid boss packaging would do.
Oh, I know, right? No, this is international shipping at its finest, I'm sure. No. Well, this was a lot of fun to help share kind of some more of the behind the scenes here of the simulation setup. So I hope everyone enjoyed it, and looking forward to the full lid boss story.
And I've seen it. I worked with you through this project, and I learned a ton today. Still, I think Michael, to me, again, my passion and background on the sim side is still been on the desktop. I haven't had the opportunity to work here, and watching you go through this, it's not scary. I hear about Abaqus, and I think of these PhDs locked away doing these crazy high-end simulations, and you watch through the workflow. You've got that, what is it called on the right, the design checker, your simulation checker, where it gives you the green checks, kind of walks you through the process. Everything inside of the tool definitely is user friendly. So if you're new to simulation, you've got Solidworks, check it out. And if you're using it and you want to get more involved into some of these higher level studies, the Simulia tools that we're seeing here today, they're available. You can use them now today. Check them out. Work through your reseller to, obviously get a license to access them. You can plug through them and start getting studies run right away. This was phenomenal. I want to say thank you to you, Michael, for coming on and showing us some of the background of walking through this. Everyone in the audience, you guys always appreciate you coming on, interacting in the chat. If you are loving these, we're doing all sorts of cool stuff. We're doing SolidWorks design, cloud design, subdivisional design, simulation design, rendering, all of those throughout the year. So make sure to like and subscribe on our channel. That is the best way for us to know that you guys want to see more. So make sure to do that and tune in, because we have more coming. In fact, we'll kick over. Jess, if you want to pull up, I want to do a plug for next week on May 17th. We'll be having Manufacturing Live, and one of our coworkers, Tandy Banks, Tandy B, super knowledgeable guy. He's got, I don't even know how many years and years experience actually in packaging design, in manufacturing. He's going to come on and he's going to be talking a little bit about manufacturing design. And then on the 19th, next Thursday, so less than a week out, we're getting the whole group together. So Michael Steeves, myself, and there was about 4 or 5 other of us, including the guys over at CAD, the brains behind Lid Boss. They're going to be joining us on SolidWorks Live to talk about the whole project. It was a phenomenal project. We got to dive in with the customer, hear their challenges, the real world design challenges, their timeline, and throw those at the 3D Experience platform, 3D Experience Works, to really put it to the test, see how well it worked in a collaborative environment, and all of these solutions plus more on high-level simulation, BOM management, customer feedback cycles, engineering change orders, product rendering. It's going to be all talked about next week on May 17th. So again, I can't thank you all enough for tuning in. Again, like and subscribe, and we will see you next Tuesday with Tandy on Manufacturing Live. You guys, everyone have a great weekend, and we'll hopefully see you soon.